So about 3 years ago, I added two extra batteries to this UPS here, and it's been pretty reliable and given me what I wanted, which was extended runtime. But now the batteries are starting to age, and last blackout it lasted barely an hour. So I'm going to look at modifying a more modern UPS with a much larger battery. So I've got a couple of these laying around that currently don't have a use, and it's a much later model than that cream coloured UPS I just showed you. That one's, I realise it's almost 20 years old. I mean, it still works, but this one I like it because it's got the display and it's a little bit more configurable. So what my goal is, I mean, this thing's been sitting around for 4 years as it is. It's time to put it to use, but the battery is probably well and truly gone in it. Yeah, it is a Back UPS Pro 650, and even though it's a 650, it's actually only 390 watts. I've actually got the exact same one on my desktop computer, powering that. Stop, halt. It's so old that the not old, but you know, things sit around for too long, the sticky stuff breaks down. Anyway, we're not here for sticky stuff. Let me show you the battery we're going to try and run this on. So, one thing I've always wondered about UPSs is that they've never made a low-powered UPS with a big battery. Because what if you want to run your router and your low-powered equipment for more than, you know, what do they say? Runtime. What's it got? Yeah, 64 minutes runtime. But it's maybe at like, yeah, you're not going to get 64 minutes out of that battery if it's drawing any reasonable amount of power. So the other one I think says 22 minutes at about 60 watts. Yeah, anyway. So we're going to try and run this bad boy on the UPS, which is a 60 amp hour lithium. And if you know anything about this kind of stuff, you're going to say, Mike, you can't go chucking a lithium battery on a UPS, but I've already done a little bit of the math and it may actually work out. So yeah, you generally can't just go chucking a lithium battery in the place of a SLA battery. But I was doing some thinking and we may actually be able to get this to work. And if we can't get the UPS to charge it satisfactorily, I've also got a backup plan, which involves disabling the charging circuit in the UPS and having an external charger on the battery. So that way the UPS just uses power in the event of a backup. But I noticed that both SLA batteries and lithium batteries float at the same voltage of 13.4 to 13.6. And I noticed in the app that is on my computer that runs the exact same UPS on my desktop, it pretty much shows it floating at 13.6. So I thought, okay, we might actually be able to use a lithium. The only thing I'm worried about is it's got recommended charge voltage of 14.6. I don't know the charge profile of the UPS, so I'm probably going to take a look at that quickly and go from there. Alright, so first up, we're just going to get access to the battery so that we can watch what it does while it's charging. So I've actually just checked the battery, and it actually surprisingly looks alright. It's 12.57, which is full. I'm actually genuinely surprised it's that well charged. Guess it's a good quality, genuine battery. Anyway, let's find a battery that's not charged and hook it up. Okay, so as we can see, we're got all the displays up, which is what I like. 240 volts out. So it's currently saying online, there's a power plugged in, but it's flashing battery, so that battery may actually be no good. But we'll just give it a few minutes and then we'll come back and see if it's okay. It was showing, what was it showing? 11.28 or something. So we'll come back in 5 minutes and see what it's doing. Okay, so without the battery connected, it's actually putting 13.6 volts, which kind of tells me that the charging circuit they use in these UPSs is what I call a dumb charger. Basically just a very low current, holds the same voltage, and then it, as the voltage gets close to that value in the battery, the current will obviously reduce. I actually used to work for a company that was a service agent for these like 20 years ago, back in, actually it's longer than that now, geez, 1999 to 2001, and we used to install like a refurb kit, so it had like power MOSFETs, capacitors, and a BIOS microcontroller update. We never had the really good service manuals that told you how it operated. I guess that's kind of proprietary. Okay, so it's smart enough to know it's not charging the battery, obviously, so if we plug the good battery in there, let's see what happens. Okay, as soon as I plug that battery in, which is actually surprisingly good, it stopped flashing battery error. So I'd say this battery, which I thought was perfectly good, it's actually a brand new one, I just float it every couple of months, is no good according to the UPS. So let's do an experiment and see if we can plug the lithium into it. Will it show good or not? Let's find out. So yeah, I actually got this battery on special at King's. $150. I mean, they're pretty much always on special anyway. Never bought anything from there. Every day they have like different deals. So yeah. So what I'm going to do is hook this up to the UPS terminals and see if the display on the UPS shows, well, it shows that there's no battery fault. Because if it does show a battery fault, then we're pretty much not going to be able to do anything. Okay, so I also bought these from Bunnings. I was going to make my own, I usually make my own cables and stuff up, but they had this stuff all pre-made. And whilst it wasn't super cheap, it wasn't stupidly expensive either. So this one's got 2 lugs, the right, well, I hope is the right size. I'm guessing is the right size to go in here. And it's also got like a little voltage meter. So even though I've got a heap of these little voltage meters laying around, I thought that's kind of convenient because I want to connect one of these Anderson connectors onto the actual UPS, so I can plug the battery in from the front or the side or wherever. To make it a little bit more tidier than last time, because if you watched my previous video, not ideal the way I did it, but this is going to be a little bit more professional. So yeah, got another Anderson plug with a fuse, which is what I wanted. There are internal fuses in UPSs, but I actually don't know what value fuse this is. Let's have a look. 20. Okay, I've already previously calculated that if this UPS it's a 390 watt UPS, if it's drawing the full rated 390 watts, it'll be about 32.5 amps that is drawn from the battery. So this is meant to be 50 amp. Yeah, 50 amp. So it's got 20 amp fuse in it for some reason. So if it changes over, I suppose it'll be all right as long as we don't pull a big load off of it. So anyway, let's hook it up and see how we go. Okay, so we're hooked up. We've got our high current thing going to our Anderson connector, which is temporarily plugged. They just the lugs happen to fit inside the clips, which was kind of convenient. But we're not going to draw any significant current off this just yet. So this is just a test to see if the UPS will be happy to have a lithium battery plugged into it. So 13.2, no, just joking. I'm taking the sticker off. 12.9 volt, and we've got 13.8 now open circuit on the UPS, which is kind of interesting. Anyway, let's plug it in and see what happens. It hasn't caught fire. That's a good thing. You can see that 12.8. Multimeter charging showing, is that even connected? Yeah, it is. What's that showing? 13.2, and that's 12.8. That's not very accurate. Trust my multimeter over that little display. So if that display is not working, we may have to return that. But anyway, that's connected, and the UPS is happy. It is saying full charge. So my real question now is that it hasn't blown up the UPS and initially it works, is will the software show the change in runtime? Because you're going from a 9 amp hour battery to 60. The other UPS I never plugged it in to a PC, so I never actually saw. It did run significantly longer, but I never actually saw what the firmware on the UPS thought of it. So what we're going to do now is plug the UPS via USB into my little test rig, and we're going to see what the software has to say about it. Okay, so we're just going to install software for the UPS, so you don't really need to sit through this, so we'll just fast forward through it. Alright, so we should get some runtime remaining, 562 minutes. UPS load 0, yeah, that's right. Battery status 98%, 13.2. That's not actually true because it's, like I said, it's lithium, so the voltages are different over. Main difference between a lithium and a lead acid is the lead acid will slowly decline over time as the battery flattens, whereas a lithium will hold in the 13s until it's at like 20% and it'll suddenly drop off. So when it's saying 98%, battery 13.2, which is actually what my multimeter is showing, and it's not what that little shows 13.1 when you first turn it on. So if it can get to 13 point, this will get to 13.6. On my desktop computer that shows 100%. So if it takes a long time to get there, that's okay. Well, I don't expect this to be accurate because it's not obviously calibrated for a lithium battery, but my question is, will it just work? So I don't care about it being accurate necessarily, but I just want to know that it can charge the lithium battery to 100% and then use it and not spit chips when it's getting 60 amp hours of storage compared to 9. So yeah, what should we do next? I'm just going to hook up the current from the multimeter because I'm interested to see if there's actually any current flow going into the battery, because if there's not, then we're in trouble. But if there is, then I think we're more likely going to be okay. Alright, so there's no fuse in there, showing that the battery is fine. So if we disconnect, I really need 3 hands to do this. So that should now show. Oh, how dodgy is that? So this fuse holder is shorted. Yeah, okay, that's not good. Wow. Anyway, we'll come back to that, and I think I might be going back to Bunnings on that one. Here I was saying, oh, that's pretty. I mean, it's convenient that it was all set up, but that's not good. That it's there's a short in the fuse holder. So we'll come back to that. It's not a very good find. I mean, imagine if you were me and you, or anyone, and you just plugged it in, thinking it was going to work, and you're setting up your caravan and whatever, and then bang, no fuse. Alright, so we're just going to hook that up to there. Now that's active, so put that on there. That should show us current, but it's not. Okay, I just hooked this up, but I've got a feeling that the fuse is blown in my meter because worst case this should still be, it's still flashing no connection. So yeah, I'm just going to check the fuse in my meter and we'll be right back. They never make it easy to get to fuses, do they? It's always like, oh, you're going to freaking destroy your multimeter just to get to the fuse. Yeah, okay, it was actually easy once I took the screws out, funnily enough. Look at that. It's got, who's done that? Have I done that in the past? Or I don't think maybe I did do that. I've just put some wire across the fuse, because obviously didn't have a fuse. So I don't know where I got this multimeter from. Can't remember if I did that or not. Anyway, let's try and find a correct fuse for it, but that's definitely blown. So let's get a fuse and fix that. It's like 400 10 amp fuses. Lifetime supply there, right there. Okay, so good news, we have charge current. 582 milliamps charge current. So that's a good thing. It's showing that the battery is connected, and it is showing that the battery is in and charging. Actually, I just realized I'm going to Bunnings this morning, so I'm actually going to unplug this and return it. And I'll leave this. Oh, geez, do I return both of it? Because that's not even accurate. But then I kind of need this, like it's the perfect setup, you know? So I don't know. I think I might just return it. Like I said, it was about 40 bucks for both, and I don't want to pay $40 just for a bit of wire and an Anderson connector. So I'll go swap it at Bunnings and see what happens. Maybe I can find a different product, something that doesn't have the voltage gauge on it. Just get one of those and see if they can find one of these that actually works. Hey, and we're back. It's about a week and a few days since the last part of the video. So I went to Bunnings and swapped those two dodgy connectors out with these two. So I just connect one on each end, one on the UPS, one on the battery. And also got this guy off eBay. Apparently the instructions are a little bit unclear, but from what I can gather, it will measure power in watts and also current in amps. So we can use this to determine how much charge goes into the battery and how much comes out of the battery. So what I'm going to do is just let the UPS charge this up all the way until the UPS thinks it's full. Use this to see how much goes into it. Apparently this comes 30% charge from the factories, and to do with transport restrictions. So we should see quite a bit of current, probably 30, 40 odd amp hours. You never get the. Do you get the exact amount? I think with lithium you actually do get pretty close to the stated value, don't you? So anyway, let's just hook it all up and we'll find out. Okay, so hook this up. So as you saw, I just chopped up the connectors. Actually fits quite snug in there, but I'm not going to leave that permanently like that. I'll probably end up soldering it somehow. Well, I suppose it's actually pretty good like that. It'll probably be perfectly fine like that, to be honest, because same surface area as a spade connector. So anyway, let's hook this up. So what do we got here? We've got source and load. Alright, so we'll hook that up to the battery. Point. Yeah, that's pretty accurate. 13.2. So I'm assuming that's like a watt hours and amp hours. Well, this is AP. Yeah. Anyway, let's plug it into the UPS and turn it on and see what happens. Load. Alright, so what are we showing? We've got 620 milliamps or 0.62 amps, so that's pretty much on par with what we were seeing earlier with the multimeter. 13.25 volts, that's the current watts, and that is the total watt hours, amp hours, there we go. Alright, so I'm just going to let this go for the rest of the day until it charges. I might actually give it 24 hours, considering it's the 620 milliamp hour charge rate. So I'll come back this time tomorrow and see how it went. Okay, so that's charging away. I just had a thought. I want to keep an eye on the temperature of the charger in the UPS, and I'm going to do that using a thermal camera. So I may actually have to modify this long term if it's charging for a lot longer and also providing a load for a lot longer than it's typically designed to do with a 9 amp hour SLA. We may have to look at a cooling solution for it. So we're just going to take a look through a thermal camera and let's have a look. That's through the side. So currently it is 11.9 degrees in here. and we're getting a hot spot of around 30. Let's say about 20 odd degrees differential. It's in the vents there. Yeah, it's getting warm, not worryingly warm. I'm actually thinking I might open it up, and I'm kind of curious to see how it's internally cooled anyway. And I've also got a project I want to do, which is using an tiny 85 microcontroller and hook up a little thermal sensor to it and a fan, and just have it as like an automatic cooling device if we need it. So anyway, let's open this up and just have a look. Okay, so we got it open, and yeah, not a lot of componentry in here. No heat sinks and stuff either. You got these metal, not sure what the idea of that one that is. Yeah, a couple of relays. Notice there's a thermistor over here, which is in an odd place considering this is the top, so you think you would have it, you know, where things are actually going to get hot. For that spot to get hot, yeah, the whole unit's going to have to get pretty damn hot. So usually you'd have a thermistor on the transformer, the MOSFET. Oh, that's what those are. They're heat sinks. The MOSFETs are behind there. I was wondering where they were. I thought maybe they're on the other side. But anyway, so we're just going to plug this in and charge and just see what gets hot. Yeah, this transformer here still feels a little bit warm. But we're not going to touch any of this, obviously, once it's powered on, so we're going to rely on the thermal camera for that. So let's plug it in and see what gets hot. So it's powering up, and charging any second now. There we go, 0.58. Alright, so we'll just give that a minute and then we'll see what the thermal camera sees. Okay, so we're just looking at it through a thermal camera after it being turned on for a little while, and we can see there are some components getting close to 50 degrees. So when we look on the board, we can actually see that those are resistors, current limiting resistors right here. So this is the area that's getting all hot. So yeah, kind of two minds about it. I mean, it's probably designed to run that hot anyway, but when it's operating, it doesn't even have proper heat sinking. I've noticed on this UPS, as is with a lot of low-end UPSs, is there's no proper heat sink. I mean, these solid metal things here are the heat sinks for the MOSFETs that you can't actually see they're in behind there. But they kind of, to me, this is a design that would be intended for short runs of use. So obviously there's a lot of material there to absorb the heat, but it's not easy for the material to let go of its heat. There's no fins on it, it's just like a block. And I've noticed the same thing in a lot of other brand UPSs, especially the smaller ones. The larger ones obviously have fans and stuff. So I definitely think this could benefit having a fan either way. Putting some cool air in this area where it's getting hot, and also on those heat sinks once it operates. But anyway, we'll just leave it running, charge up that battery like I said, and we'll come back in a day. Hey, so we're back, and it is almost 2 weeks later. So I just left it charging. I know I've had some other things I had to do. So anyhow, let's have a look at how we went. So I was just thinking, how much charge has the battery taken over almost 2 weeks? So 60 amp hour battery, it comes 30% charged, as is notified here. So that's what, 18 amp hours, give or take, that it comes pre-charged. And how much is it charged over last week in a bit? Let's have a look. Come on. 37.8. Okay. What's that, like 55, just over 55 amp hours? So that's actually pretty good. That's more than I was expecting, to be honest. I was only expecting it to get 45, 50. So 55 amp hours, is it even worth worrying about modifying the charge circuit? Because I've been going through some theoretical designs that I could use, either if I modify the existing charger in the UPS, or if I add like a piggyback charger just to give it a bit of a boost up to 14.4 volts and then shut off and then let it sit down to its trickle charge rate. But that's actually not terrible. Anyway, the next thing I want to do is actually, now that that's charged, is I want to reverse these and run a load on it and see how much is drawn from the battery down to empty. So I'm going to set that up, and it's probably going to have to run for, the whole day. So we'll find out later tonight how it went. So let's set that up and see how we go. Okay, it's hooked up, and unfortunately it's now upside down. Not to worry. Just to shuffle it all around a bit. Anyway. So I'm just going to stick a thermocouple. It's currently 14 degrees, that's about right. Thermocouple on the heatsink. So I was interested to see what temperature it gets to while it's running. That was very smart. I'm just putting some thermal paste on the end of the probe and stick it in the heatsink like that. Get that to stay still. There we go. So yep, 15 degrees. So we're going to plug a load on. Just thinking what load I could plug on. I'm going to find a load. Okay, I was hoping I had like a 60 to 100 watt light load laying around, but I don't. So what I will plug into it is this little media computer that I was mucking around with. So I've actually, if that messes up, it doesn't matter. So I can use that as the guinea pig. Just try and carefully plug that in without electrocuting myself. Hate doing this. It's not live. No. There we go. It's in securely. So we've got that set up. That's plugged in. So this thing should still stay powered up once the battery gets low enough. And we're going to measure the total power out of the battery. So yeah, we're good. We're going to power it up. Okay. So that's currently unplugged. I forgot that I unplugged it. So yep, saying on battery. Okay, cool. So how many watts is it saying? Load 0 watts. Probably because we need to turn it on. There we go. So I'm not sure how much power this draws. Maybe 6 to 10 watts. So pretty close to what the router would use. What do we got in the watt meter? 2.1 amps, jump around a bit. Okay, 30 watts. Yeah, okay, that's not a bad load. So, I mean, we can see how long it goes for, but I'm more worried about how much power is actually going to go in and out of the battery, because we can work that out later. So, alright, we're just going to let that go, and I'm going to some more couples in there still in the heatsink. So I'll see what kind of temperature it gets. I'll just keep an eye on it. If anything significant happens, I'll put a little update in, but other than that, we'll just keep it going. That's booted up, and 30. That's good. I want it to use a bit of power, so that's probably about the same as 2 routers. So yeah, let's see how much current we can pull out of that battery then. I just want to give a quick disclaimer too. Please don't copy what I'm doing. I've been doing this kind of stuff for a long time. I have a restricted electrical license and a diploma in electronics, so I'm not just mucking around with this stuff. I do know what to touch and what not to touch. And that's why I'm not really giving a lot of advice on what you can and can't touch, because I don't really want anyone copying any of this. But basically right now, if I touch these 2 poles, I'll get a fair boot, and yeah, you don't want to do that. So please don't open these up and poke around unless you know what you're doing. So just thought I needed to put that out there. Okay, so it's been about half an hour, maybe just over half an hour. So I'm still drawing around between 20 and 35 watts. It jumps all over the place. And we just saw 2.7 amp hours. And the temperatures are actually looking pretty good. There's a couple of warm spots around. Sorry about that reflection there. Maybe you notice the transformer's getting a little bit warm, but nothing to worry about. There's a couple of other spots in there too, getting warm, which I worked out is there's like a heat sink there for something. I'm not sure what's attached to that, and also a coil. So yeah, in all, it's nothing much to worry about. I think I might still put a fan in there though, just in case. I don't know. I'm thinking I should probably load this up a little bit more too, just see if that generates more heat. But this thing isn't going to see more than 50 watts of power anyway, because it's literally just to run our internet during a blackout, so it's not very heavy duty. But if I do use it for something else or add something in the future, I'd just like to have that flexibility there. So if you're not familiar with the workings of the UPS 2, I'll give you a quick run through, because I realised I didn't do that before. So you basically got the mains comes in, you got a heap of relays here. The microcontroller, which is under here, controls the show, so keeps an eye on what's happening with everything. So usually you just have mains come in. It will, I've worked out this is the transformer for the low voltage, so that this area here charges the battery and also provides power to the microcontroller. There's a what is it, 7805 regulator there, giving 5 volts to the microcontroller and the control circuits. So when there's a blackout, these relays switch over. So it basically takes 12 volts out of the battery, and you can see them come up alongside these heatsink hole things where the MOSFETs are. So then those MOSFETs will switch at 50 Hertz and provide basically 12 volts switched at 50 Hertz into this transformer. And that transformer turns the 12 volts up to 240 volts, which is then filtered and sent out to the load. So in a nutshell, that's how it works. I've noticed there's two, it's actually got 80 amps worth of fusing, I think, for the battery too, which is interesting. 240 amp fuses there. So yeah, surprisingly the MOSFETs aren't really getting that hot, or at 30 watts anyway. But it'll be interesting to see how much hotter they get if we pull a larger load through them. My guess would be the transformer would be what gets hotter. The MOSFETs are just providing the switching, and the transformer is what's providing the current. So yeah, we'll be back shortly to find out the total amp hours we can draw out of that battery. So just an observation, I noticed that the battery volts is still at 13.2 something, and it is saying 24 watts a draw. But then the UPS display, I've noticed, says load 0. Sometimes it'll go to 20 watt, but mostly sits at 0, which is unusual. Also the battery gauge here too. It regularly goes between nothing and 1. And well, obviously it's not going to be accurate. But one thing I was interested in, I'm wondering if it'll actually recalibrate itself, because I know that these things recalibrate themselves as the battery starts to age. But what if the battery has significantly more capacity? So I'm wondering if after this discharge cycle, it may actually calibrate for 55 amp hours, or around whatever's in the battery. So yeah, I guess we'll find out. Hi there, so the time is now 8:05, and this is the next day after we started discharging the UPS. So, how's it going? It's been 30 hours now, just over 30 hours. Still drawing between 20 and 30 watts. Let's see what the total current is. So 30 hours later, yeah, it's mini PC still running. Whoa, 61.5 amp hours and 806 watt hours. That's the battery says it's 768 watt hours, so either we've got some kind of rare super battery that's got more than 60 amp hours of charge in it, or this thing's not entirely accurate. So what's the batteries? It says battery's under 12.84 volts. It's still got a bit of go left in it, so I guess we'll just leave it going overnight and see how it went in the morning. Yeah, alright, I'll see you tomorrow. Hey there, so it's the next day. So 974 watt hours. How many amp hours did we get? If this thing got some crazy number, I think it's going to be inaccurate or something. 65. Sweet. Okay, that's pretty good. So now what we're going to do is what's on 11.53 dropped out. Okay. So anyway, we're going to reverse this doohickey again and see how much charge current goes back into the battery, and see how many days this takes as well. Okay, so that is powered up and charging. So I'll see you in a couple days and find out how much current goes back into the battery. Hey, so it's like a week later now. Let's have a look at how much, hey, 65 amp hours. That's a lot, considering that the battery is only 60, so there's either two things that's happening here. It's either we've got a really good battery, or this thing is not so reliable. So I was thinking the only way I can really prove if this thing's reliable or not is to drain the battery once more and hook it up to a smart charger and see what the smart charger says. So yeah, for today we're just going to hook up a load to it, drain that battery, and see how much current we get into it when we hook it up to the smart charger. So again, we're just going to let this run for a couple of days. It's just draining the battery, and I'll reverse the connections on the current and voltmeter. So let's see how we go once this thing's discharged and we charge it on the smart charger. Okay, so now it's 2 days later, just over 2 days later actually, 2.5 days later, and the battery is finally down to flat, being 11.4. And I think I saw it before come up 65, there we go, 65 amp hours, so exactly the same amount of charge that we had previously has been drained. So now we're going to hook that battery up to smart charger. So unfortunately it doesn't have a display on it, but it's got a Bluetooth app. So once you start a charge cycle, it'll automatically add it, and once it's finished, we'll be able to see how many amp hours went into the battery. So yeah, interesting to see whether that was accurate or not, but I guarantee this will be accurate. So anyway, let's get it charging. Charger app. We should be able to see. So we've got 11.5 volts. You can select between 2 and 4 amp, but I'll keep it on 2 amp. And we should have graph, currently bulk charge, history. So this one on the left here is it's just started at 0 amp hours. Start at 11. So yeah, interesting to see what we find. So let's give it again a couple of days and see how we go. Okay, so we're back. So it's a few days later again, and smart charger is finished. So let's see how we went with the charge capacity. It's connecting by Bluetooth. And we've got, it's currently floating, so 13.67, which is exactly the same as what it will float in the UPS. History, so we've got 11.4. Okay, so let's see what's happened here. We had a small blackout the other night, because I know that because the microwave went flat. So this is our start, 11.4, as we saw the other day. And it continued here, 13.10, and is now finished at 13.52. So what have we got? 48 plus 92. What's that? 52, 53 amp hours? 53.2 amp hours? Sorry, I just did the calculation. It's actually 57.2 amp hours. So yeah, that's pretty good. At 60 amp hour capacity. So Interestingly though, this thing's always said 65 amp hours, and it's actually 57.2. So my suspicions were correct. This cheap current metering device is not all that accurate, but at least we found out through the charger that that's what we can actually put into the battery. So yeah, alright, so I'm not going to worry about modifying the charge circuits in the UPS. But one thing I'm going to do is put a fan cooler in it. I've decided. So even though it doesn't get overly hot, but the fact that, I don't know, because it runs up to 3 days. And these UPSs aren't designed to run that long. So anyway, I'm just going to share a project I've made on the side. Is a temperature controlled fan speed controller. So I've designed the circuit using the AT Tiny 85, and I've got some PCBs that are currently on the way, so I'll just quickly show you that design, and once the boards arrive we can assemble that and install it into our UPS. Okay, so we're going to construct one of the universal temperature fan driven controller that I've just designed. So I just spent the last, 2 weeks working on this. It's a pretty straightforward project. It's just, that's the PCB there. And these are the PCBs from PCB Way, who do not sponsor anything. And it's probably lucky they don't, because I noticed that one of these boards has, I don't know if that's, I don't know what's going on there, but I was just going to take a look at it under the microscope and see exactly what's going on, if that board can even be used. So let's get our microscope out and take a closer look. What's going on with this trace? Yeah, there we go. What is going on there? Doesn't look damaged. Actually, it does a little bit up the top there. What on earth caused that? So, yeah, this is one thing I generally do. I always give boards a... I usually go through JLC PCB, but I usually give them close-up inspection for that very reason. So there's another bit of a thing there too. So generally, boards are all pretty good, but yeah, occasionally, I mean, this is the first time I've used, what is it, PCB Way. So yeah, maybe I'll just go back to using JLC PCB. I've literally never had a defect in any of their boards that they've sent over the years. Yeah, the rest of that looks alright. Anyway, so we'll just not use this board. I mean, they're pretty cheap anyway, so I'm not overly worried. It's just, yeah, that board will be no good. So we only need one for now, so it's not a big deal. Pretty cheap. It was like, because it was like a first sale or first customer. It was like $5 delivered for, you know, like 10 boards. So all things considered, I'm not too worried. This board looks to be alright. Bit of a thing there. Or is that a VIA? That's a VIA. Yeah, so anyway, I'm not going to do the audio for the rest of this because you probably heard I've got a pretty bad head cold at the moment. So I'm just going to assemble this and we'll just speed through it. So yeah, here we go. Okay, so we're ready to plug the microcontroller in, which we've programmed with my makeshift programmer. And I just quickly tested the voltage coming out of the regulator going to the IC socket for the microcontroller, and it was putting out 3.5 volts. So I just quickly removed the old one and put a new one in. So we should see where are the pins? Oh, duh, turn it on. Okay, red light. If I can remember what the pins are for the power. What was that one and that one? Yeah, there we go. 5 volts. Or minus. So 4.97. And it looks pretty stable. So, alright, I think we're good to plug our programmed microcontroller in. So pretty much what this setup is, we've got two LM35 temperature sensors here. So the idea is we stick these onto the hotspots inside the UPS. Now I actually cheated writing the code for this because I just wanted to get this project finished. I gave AI a shot, just the Microsoft Bing browser. I told it, it actually got it wrong. I told it
I should have recorded when I did it, but I told her all the details of everything, and it fully messed up the pinouts. And I said, no, that's not right. And it's like, you're right. Blah, 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 blah. Then it corrected it, but it didn't correct it properly. So I had to be more descriptive of the pinouts, and I had to make a few small corrections. But the code compiled and uploaded to the microcontroller okay. So I'm interested to see if it just works without really doing too much. So, yeah, pretty cool little controller. I actually made it a little bit more feature-packed than I originally thought. So yeah, you got your two thermal probes there, which are LM35s. I've also added a jumper for one of the spare, because I wanted to use all the pins that were available on the controller. So I had a spare one. So I actually thought I'll have step or sine wave as the two fan curves. So basically what this thing does is at around 40 degrees, if it's on stepped, between 40 and 50 degrees, it will run the fan at 50%. Between 50 and 60 degrees, it will run the fan at 100%. And if the temperature goes over 60 degrees, I've got a status LED. It will flash a specific sequence. It also has power on diagnostics. So again, the LED will tell you if either of the temperature sensors have a problem or they're out of range or not connected. And yeah, it should be pretty good. The microcontroller drives a little MOSFET. What is it? RFP 30N06LE. I like these MOSFETs because I think they're actually discontinued now, but they're they have static resistance in them, so you don't have to worry about static electricity so much damaging them. Yeah, but going back to that jumper, if you take the jumper off the sine wave mode, it will progressively speed up the fan between 40 and 60 degrees. So like every degree will cause a small increase in fan speed increase. So yeah, it should be good if it works. Let's see how good AI is at writing code. So anyway, we're just going to move the chip into this and make sure it powers up, and then get a couple of cups of hot water of different temperatures and see if it works. Okay, so the big test. I've not powered this up yet. So they're going to go poof, not work. I think we should see 5 flashes on the LED. So yeah, it's actually been like 2 days since I went through it. Anyway, I'm just going to hook a fan up to one of the headers. It was actually designed for like the same headers that you have on like a motherboard for a CPU or system fan, but the pin spacing and just the regular pins, although 2.54mm pins is the same, so it didn't matter that I used those. So here we go. Is it going to work? We should, like I said, 5 flashes, and then I think it's one short and then a long. I actually need to. I want to rewrite the code because I realized each sensor it'll show the light for 5 seconds, but then I realized after there's actually no way to determine which sensor isn't connected, 1 or 2. It'll just say one of them is, but not which one. So anyway, let's power it up and we should get 5 flashes. Hey, 5 flashes. 3, 5, and there should be a blank, and then a flash, and then a second flash. Pretty sure it was meant to be a second flash. Okay, so it's only flashed once. I'll have to go back and look at my notes and see exactly what's going on there. But might just get a cup of hot water first that is 60 degrees, and we should see the fan turn on. So regardless of whether that jumper is on, it should run it in stepped or sine, like one or the other, doesn't matter. So anyway, let's go get some cups of hot water and see what happens. Okay, so we've got our cup of water. And it is boiling hot at the moment. So I was just going back through my notes for how the code's meant to work, and it's meant to flash 5 flashes when it turns on to let you know it's working. And then one long flash to say sensor 1 is working, and a second flash to show that sensor 2 is working, and then a single or a double flash based on to tell you if the jumper is set to sign or stepped mood. But it didn't. I don't know. This is the first time I've powered this up, so I don't know if there's bugs in the code, but I'm hoping it just works. I've got a head cold at the moment, and I just really want this just to be done. There, 5 flashes. Now it's meant to do 2 long, or 1 long. It should do 2 long. And 1 flash to say that the jumper is off. So every minute, I'll actually put a screenshot of what this thing is meant to do. If you're actually interested in this project, I'm happy to share it. And yeah, just let me know in the comments below if this is something you would use. Alright, so both of those are in the water. So every minute it will get a reading from the sensor, so this will take a little bit of time. Actually, I'll speed it up. Yeah, so after a minute, it should turn the fan on. Every minute it adjusts, it takes a reading and adjusts the fan appropriately. That way it stops something's not putting out a lot of heat. It'll stop it from surging, constantly turning on and off, on and off, on and off. You just want nice, smooth fan movements. How often? This LED is meant to flash every 5 seconds when it's in standby mode too, and I just noticed it's not doing that. So this doesn't turn on in the next few seconds. I'm going to have to go check the code, do some more troubleshooting. In which case, I don't want to spend too much time on this in this video, because this isn't the core of what is going on. This is just meant to be a side project. Cool, the UPS. So I might just debug this and get it working. So yeah, alright, I'll be back once it's working.
Okay, so it's actually been over a month actually, since I recorded that last scene. And to cut out a long story short, I made a diagnostic program for this to try and work out what was going on. Had to make some changes to the prototype board. And then what did I do? I accidentally wrote the wrong program to it and it fried the microcontroller. So RIP, poor little microcontroller. I also found out that I'll put the datasheet up on the screen right now, but these temperature sensors aren't designed to be run like this directly off of a microcontroller or whatever. You've actually got to have some other circuitry on it. So yeah, so this is the demo one. I noticed what was happening was the voltage was, but basically this wasn't working, and I was trying to work out why, and the voltage off these little sensors was floating between millivolts and 1.7 volts. It's meant to do I think it's 0.025 or 25 millivolts per degree of temperature. I can't remember the exact figure off the top of my head, but in the datasheet it actually showed a filter circuit. So I basically made a bit of a ad hoc one here, and the voltage stabilized when you measure it between earth and signal, except at that point I fried the microcontroller. So I thought, right, I can't do that, that's just messy looking. So what I did was I redesigned the circuit board and got told off by PCB in the process, because apparently this is 3 PCBs now. I did actually make it so that you could snap these 2 little boards off. So basically you mount this onto the 2 boards there, except I had to make it look like one board because they tried to charge me $49 for 10 boards to modify it with those 2 little boards to cut off. And I said, that's insane. I could literally make the 3 separate boards cheaper than that. They ended up letting me off this time, making them on there. So anyway, it's funny enough, these boards seem to be, I was looking at them really closely, they're a lot better quality. Those first boards I got that were a bit average, they had a
don't know if you notice there's like a scuffing on them. These ones look to be a lot better. So anyway, like I said before, I don't want to spend. I just need to get this done because it's now been like several months and it's the only project and video that I've released in that time. So I'm just going to fly through this. I'm going to cut these off, put this board together, and hopefully it will work. So I'll see you on the other side. Hopefully we've got a working temperature controller.
Okay, so that's most of the components, and I actually received this today, my new soldering iron wand to replace the old one. It still works, but yeah, the plastic's gone all brittle. Yeah, I've had this thing for years now. Like, I reckon I bought this in like 2016, 939D. You can still get it, and you still get parts for it, which is really good. I paid like 35 bucks for the whole thing, and it's only just now I started falling apart, which is, I think, it's pretty good for a cheap Chinese iron. But now they go for like $80+, so yeah, that's kind of interesting. Anyway, I'm not going to jibber jabber. I'm just going to get this done. So back to it. Okay, so this little sensor board is pretty much what the datasheet requires to reduce noise on the sensor. So we've got two capacitors and a resistor, and also some shielded wire. So the signal goes on the center, ground on the earth, and power wire. So hopefully this should cause much better stability in terms of the temperature reading. So this kind of protrudes out like that on purpose so that I can glue that on the component to be measured in terms of temperature. So the hot transformer or the MOSFETs or whatever is getting hot. Two of those made now, so I'm just going to put some heat shrink on them and attach them to the main board.
Six and a half hours later.
Okay, so I have just spent probably close to 6 hours diagnosing my little module here. It's a simple project that has ended up being incredibly elaborate. So I had some trouble in the code that was making it run like lightning fast. So once I sorted that out, I found out that two of the wires were, or two of the pins on the microcontroller were mismatched. Pins 6 and 7 were accidentally swapped around. So I fixed that and then found that it wasn't measuring any temperature. So I've then found out that the temperature sensors that I bought are fake. They're meant to have a range of 5 to 20 volts. I don't know if you can see that. It's a bit of a... Yeah, they're meant to have a range of 5 to 20 volts, but you go putting any more than 5 volts in these things and they get red hot. So if you put 12 volts in them, they get really hot, and they shouldn't do that. So I'm going to go to Jaycar tomorrow, and I didn't pay much for these. I don't know, it's my own fault for
buying cheap garbage off eBay. So Jaycar, I've got something that's kind of similar that I can use, except my little filter board here that I created for these will be obsolete, but that's no big deal. I just want this to work. Fortunately though, it seems to be a little bit simpler, so I'm going to use an LM335Z. So I only need a 2.2K pull-up resistor. I don't need any filtering, so I've actually used a shielded cable, because it recommended that in the data sheet. Trying to get a stable reading, and yeah, not going to get a stable reading because they're not genuine. So anyway, it's now pretty late at night, so I am going to bed, and we'll go to Jaycar in the morning and get some temperature sensors and finish this project, because it's now dragging on for months and months, and I've got lots of other fun things I want to do, but I can't start those until I finish this project. So I will see you tomorrow, and hopefully we will have a working module. You know what? I was just thinking I probably could have just used this thing. It's actually a basically an electronic thermostat. It's got hysteresis and everything. It's 12 volt. Why didn't I just use this? Because I thought this would be a quick and easy project, but it's taken way longer than it should have. So anyway, if it doesn't work tomorrow, if I don't get this going by lunchtime tomorrow with a couple of sensors from Jaycar, then I think I'll just use this thing, retro mount it into the side of the UPS or something, I don't know. Anyway, we'll see you tomorrow. Okay, so fingers crossed this should work. I didn't record it because, like I said, I just want to get this done, but these sensors appear to be working, although they're incredibly expensive from Jaycar for $5.95 each, which I didn't want to spend that much, but it was the only way to get this literally done today without ordering more and waiting another week or two. So pretty straightforward. I've removed the old sensors, bit of a shame, bit of a waste of components. Removed the pull-up resistors because they're no longer required. And we have got a 2K resistor feeding the voltage on the sensor, and then earth goes back to earth, so it was pretty easy to wire back up. And using the old Microsoft Bing chat AI thing, I was able to modify the code. The reference voltage, these sensors are a little bit funny. So I was looking online, and people prefer not to use these sensors because if the reference voltage drifts, like from the regulator, for instance, the 7805, it will change the reading. But it's pretty stable. It's not really drawing a lot. It's like 10 milliamps tops I viewed on the power supply. So should work. So I think it was like 3.030 volts at 28 degrees. So I'm not a huge fan of AI. But I just need to get this done, and I kind of hate. I mean, I can program, but I don't. It's not my main key area that I'm good at. So, if AI can do 90% of the work for me, I'll just let it do it. So anyway, I gave it the reference voltage and temperature, and it reckons that it was able to adjust the code accordingly. So I'm about to test it. So it's all should be all plugged in. So here's the big test. Sorry, this is not really UPS related, it's more electronics now, but there we go. So when it powers up, the light flashes twice to say it's running, runs the fan at 50, then 100. That should do one long flash for sensor 1. 1, 2, 3, 4, 5. Okay, it's giving 10 flashes, and I did that to indicate if the sensor was out of range, but that was for the old sensors. So now it's done 2 long flashes indicating sensor 2. So I don't think that's actually accurate anymore. So if it's a big deal, I'll have to go back and change the code. But this is just a little power on diagnostic that tells me if the sensors were in range. But like I said, that was for those sensors. So okay, so the program's running, and it's decided that to run the fan. So I wouldn't have expected it to run, because it's not definitely not 40 degrees in here. bit odd. Let's just see what these. Let's see what the reading is on these again. Okay, so just measuring the sensor output of one of them, and we got 3.021. So it's giving an output that's jumping around because it's like really pretty bad connection there. So don't think that's anything wrong with it. A bit more stable. So yeah, we're getting a reading off the sensor. I think it's just reading it wrong still, so I'm going to have to change the values again. It's definitely not 40 degrees out here. It's like, yeah, 28 to 30 degrees at the moment. So let's try change the code again. So it's actually 26 degrees. So we're going to take note of that, plus the 3.020 volts off the sensor. And we're going to measure the regulator voltage too, because that'll affect the reading. Yeah, and 4.92 for the output. So we'll take those three values and hopefully we can calibrate this more accurately. Alright, so let's see how we go. Just a Copilot, absolutely, with the calibration. See what I mean? It's just so quick and easy. When it works, like I said, I have had issues with this doing incorrect pinouts and other things. So yeah, what was the main thing it did? It actually messed up timer values. It was making the sketch run like, or the code run like lightning fast, and I couldn't work out what was going on, and it couldn't tell me what was going on either. So I had to kind of just sift through using the old school search and see what other people had done, and found it out that way. So anyway, let's upload this and hopefully it works. So I realised I could have actually done that myself, because I did ask it earlier to make it so I could easily change those values. So yeah, we could put our voltage, calibration and temperature. So I was just thinking, sorry if this is not really all that interesting. This is probably more for electronics hobbyist people if they come across things, but like I said, this is a vlog. I'm just documenting what I do as I do it. So if I didn't include all this, I'm not really including the full story. So alright, let's give it a shot.
2,000 years later.
Okay, so like several hours later, I finally worked out what was going on with this. So I've been pulling my hair out all day, and I didn't bother recording it because I'm just over this and want to get it done. So in the code, I had, this is obviously where the temperature sensor is connected here and here. So I forgot that analog pins are different to digital pins when you address them in the code. So I was writing number 2 and number 4 and it was actually picking up reading this one, and I couldn't get it to read. So oh yeah, so to cut a long story short, I got it working but only on one of the sensors, and it wouldn't read off this one. So then I punched it all into AI, and it yeah, pretty much told me what I need to know, which is strange because I actually talked to this about it previously. The only difference is I refreshed the conversation. So one thing I've learned, I don't know if you find this if you use AI at all, if you tell it something and you tell it that the information that you've given it is right, so right now if I say you're wrong, PB1 is PB2, and I mess it up, it'll go you're right, and for that session it will think that it's correcting it based on the information you've given it. So anyway, let's go see if it works. I hope it does. Alright, so this would make sense because I've literally checked everything under the sun, and that makes absolute sense that I got the pins wrong. So I've actually got a fresh AT Tiny in there, no different than earlier. So we're going to power it up, and hopefully the numbers, I'll talk you through it. So there's some blue LEDs, got a bit darker. So that's testing the fan. Should now flash twice, indicating that the jumper is on. It flashes once if the jumper was off. One long flash indicating sensor 1. One short flash indicating sensor reading low, and now it will give the temperature. So 10, 20, 30, 1 and a 32. And this is now sensor 2, 2 long flashes. You should see 1 short flash indicating below threshold, which is correct. Now it will show the temperature. 10, 20, 30, 1, 31. That's good. And flash to say program started. I might, if I'd keep this as a project for other things, or if I don't know, give it away for free, like the design and everything, which I'll probably end up doing at some point. I'll probably tidy up that startup code. So now we should see a heartbeat every 30 seconds. It will do a half-second flash just to show you that it's not frozen and that the program is running. But what we're going to do now is using a heat gun. Sorry about that. We should see. Make sure it's not too hot. So the blue LED every 30 seconds it checks the temperature. We should see it blue LED come on next 30-second iteration, and it should power on the fan. There we go. Beauty. I'll wait for that to cool down. We'll do the second sensor. So this sensor was the one that was working, and this one was the one that wasn't. But hopefully it should work now. So just gotta wait 30 seconds for that to cool down. Man, I'm kind of I've spent way too much time diagnosing this. I mean, I guess it is a hobby though at the end of the day. It's not like I'm doing this as a paid job. Okay, so that's cooled down, so it's turned off. So we should see the next one work. I guess that's the joy of hobbies, hey. I guess I learnt something. I mean, the thing is, I don't use Arduinos very often, and it's one of those things, you use it every year or two, like make a project based on an Arduino, and you forget all those little ins and outs. There we go, fan's turning on. Beauty, so far out. So I mean, yesterday's issue was actually the sensors, whereas today it was more to do with the code, assigning those analog pins correctly. Took way longer than it should have, but hopefully that fan will turn off. And we can tidy this project up and stick it in the UPS. There we go. So now I've got to pick some fans. Let's go look at some fans, shall we? Okay, so I pretty much decided to use these two little fans, namely because of their exceptionally small current draw, 0.09 amps at 12 volts. So considering this, I'm thinking about using this big fan, it would actually fit. But it draws quite a bit of power, 170 milliamps, and yeah, I saw it on the power supply, it does draw that. So I'm just kind of thinking where to mount these fans. So this area gets hot, and also the transformer gets hot, so the transformer is obviously going to have some cooling. Not sure if I mentioned earlier because it was like months ago, but I actually wondered why there was a thermistor down here, and I realized that was for the battery, so that's where the battery would sit inside the other side of the plastic. But I actually realized it looks like it'll fit. I want it to measure the temperature. It might as well do something, so I'm thinking I'm just going to modify the bracket slightly just to fit that thermistor in there and glue that to the transformer just as a backup in case this project ever malfunctions. Apart from that, I'm thinking of just sticking a fan in this kind of general vicinity, so it's kind of moving air over the transformer and into the electronics. And I was also thinking of putting a second fan in the top to blow this vent is it's hard to see, but there's not a lot of, the gaps in it are like tiny and they're not all clear either, so I think it'll definitely benefit having a fan blow hot air out the top front. And I've noticed there are vents on the sides and they're not too bad, you can actually see through those as you can see there. So there's also some on the other side, so yeah, if we put a fan here, it'll suck the air up from this area and draw it through. Try not to give it too much thought, but still want it to be relatively effective. So that's what I'm going to do. Install the module into this plastic thing here. I'll glue that in here somehow. I realised that this can actually unscrew with there's like a battery box, so that'll give us clearance for the fan in the case. So yeah, drill a hole, so let's get to it. Yeah, so I just realised looking at the vent, it's actually fake vent. You can't see through it. And I thought, oh, is the whole thing like that? And yeah, it is. It has a fake vent all along the top. You can't see it. There's no light in there. There's no airflow. Whereas, you know, like this one, you turn it to the right angle and you can see through it. So that's pretty poor. So they've got ventilation down the bottom of the casing and nothing up the top. Like literally nothing. That's the fake vent. I actually thought it must have been looking at the light at a certain angle, because I swear I could see some light before, but it must have been like the reflection off the shiny parts in the grooves. So anyway, that's made me even more happier to make this choice to stick a fan in the top. Pretty poor, really. I mean, I know it doesn't get super hot, but you think in a hot, humid environment at high load, it's going to get pretty hot. I mean, I'm pretty lucky where I live. It's relatively cool most of the year, especially inside the house. But yeah, anyway, just thought that's worth pointing out. So I'm just going to stick a grill on the top, see if we can find some screws that'll fit through there. So no more jibber jabber, I'm just going to speed through this, so here we go. I'm just going to note here, even though this looks a bit hacky, I cut the old terminals off these, but that surface area is pretty much the same as a battery that would connect to it anyway. So bear in mind this is not going to be a high current thing, so it's actually slightly thicker than an actual battery terminal. So yeah, this gauge wire is thicker than what's on there anyway, so there's no concerns with how this is connecting. So it's in so tight as well. Yeah, I mean that's as good as a battery will connect to that same terminal. So as long as it's wound around the right way. That's the wrong one. Yeah. So yeah, I think she'll be all good. Okay, so one thing I want to do before I go any further is make sure the temperatures turn on at a reasonable temperature, because I mean the heat gun's set for 100 degrees, set it off, but so we've got some hot water here, 66 degrees. Let's power it up and stick the probe in. Sounded like a mini server fan. I suppose that's what they are. Anyway, we've got our sensors in the water. You see that? So what is that? Current temp 65, so it should turn on. Next question is 2, because I got 2 settings on this, and I'm not sure if I should use it on stepped or sine. I'll probably have it on linear or sine mode, so it progressively turns the fans up the hotter it gets. Doesn't really matter either way. I kind of designed these projects to be a little bit universal, so I could use it for something else with minor alteration in the future. But it's waiting for it to get started. Not seeing any activity on the LED. Alright, that should be running now. It's currently 64 degrees in the water, and it is not triggering, which is a bit concerning. So, yeah, okay. So what I'm going to have to do is play with the values in the software so that it triggers at around 40 degrees. This is not the normal weight. Like I said earlier, a lot of people don't use these on tiny 85s or Arduinos because they're a bit fiddly to get the calibration exactly right. Not a big deal, it's just going to cost us more time. I mean, hey, we've already spent what, a couple months and several hours troubleshooting and getting this thing to even work. So yeah, the light just flashed its pole, it's not turning the fans on. Alright, so just when I thought we were close to the finish line, the goalpost has been moved away. The finish line or goalpost, wherever it wants to be. So let's change the code and see how we go. Maybe I spoke too soon, because just about to unplug it after I tested it and the fans fired up. So we're at 61 degrees and the fans are running. So I think maybe I was just being impatient. I think maybe the startup sequence hadn't quite finished. Let's just sped the fan up. Huh. Alright, well I'm just going to watch this and make sure it keeps the fans on until it gets down to 40 degrees. Got some cold water that can speed things up. So yeah, so far so good. Okay, so they actually cut out when I get down to 50 degrees, so that's not good. I really want them, ideally want them to cut in when it's 40 degrees. 50 degrees, in my opinion, is slightly too warm. You might as well just not have fans in there. So yeah, let's alter the code once more. Still, at least we did this now rather than find out later. This is kind of like the last chance to get it right. Okay, so I've been pouring hot and cold water back and forth and made a couple of changes to the code, and I've got it so that pretty much at 40 degrees now on the dot it will turn the fans on. So yeah, I'm pretty happy with that. So let's tidy up all this water and we can finish installing the fans and cables, and yeah, not far to go now. Okay, just when I thought I was on the home stretch and I was not going to have any more issues, I actually had a sensor burn out. One of these ones, which is one of the ones I got from Jaycar. So I went to Altronics because they're a little bit cheaper. They're like, I don't know, $1, just over $1 cheaper. And they look like notice they look different as well. So this is the Altronics one, and this one is one from Jaycar, and the legs were splayed differently. But find a picture, I'll chuck it up here. So yeah, the part numbers are very similar. They look very similar. So I don't know if the Jaycar ones are, I don't know, a little bit something wrong with them, or I can't see how it's something I've done though, because you can actually put 5 volts in these sensors and they won't burn out. And the regulator is a Motorola. They seem to be pretty reliable. Apart from one I had, it gave out 3.3 volts. I didn't actually check closely. It may have actually been a 5303, but anyway, that aside, the microcontroller and other things would have, like the LED would have popped if the voltage, if it let 12, 13 volts get past the regulator. So I don't know what's going on, but I've replaced this one sensor, and as I was testing them in the water, the new sensor was working, and then the old sensor, the second sensor, stopped working as well from Jaycar. So not one, but 2 have eventually failed. So I'm just in the process of wiring up this other one from Altronics. So fingers crossed it works, because if these sensors keep burning out, it's just another issue upon issue. So anyway, I'm going to solder the sensor on and then give this thing a good long testing, probably the rest of the day, just to make sure they don't fail, because the total length that those old sensors were running was only a couple minutes. So fingers crossed we don't have any more issues after this. Okay, so 2 new sensors soldered on now, so fingers crossed these ones work. Good thing is about get to redo this is the other wires weren't really the right length, so this way I've been able to make a shorter one for the control board where the charge circuit is, and the longer one for where the transformer is. So let's test it again. Alright, so before we do the temperature test, I'm just going to check the output of those 2 sensors. So they should be in the range of 2.9 to 3.1. That's weird. Oh, hang on. Wrong one. Okay, so there we go. 2.975. We should get about the same for this other one. 2.956. So close enough, and that shows that they are working. How long is going to be the question, but hopefully they don't fail. Which I'm a bit annoying, because those sensors were like $5.95 from Jaycar. I can't see that I've done anything wrong that would have caused them to fail. So anyway, I'm going to put that in the water, and that should not turn on. So all I do is I just have it, you can't really see it, but I just touch the top of the sensor on the water. I can't see the water cause any problems with the sensor anyway. Might get a small amount of electrolysis having the sensor in the water, but yeah, that'd be right. 35, so that's not turning on at 35. Let's check the other one. I might just thinking, I don't know, I wouldn't have thought that dipping them in water would make the sensors faulty. I mean, they're sealed. It's just like in a 292 package. I guess theoretically you could get. Yeah, see, I don't see, even if you shorter or put the maximum voltage through, they wouldn't go faulty. So don't worry about it too much. Anyway, I'll just try and avoid having the contacts in the water. So this is at 35 degrees, so we should see it not turn on at this temperature. So 40 degrees is like the tip over, but seriously, anywhere between 40 and 45 is kind of where I want it. It's not like it's going to be critical if it starts up a little later. So I've just got hot water here, I'm just turning the temperature up. We'll try 42. There we go, 42 degrees. So we're looking for that fan. I don't know if you can see that fan back there. Looking for that fan to turn on. See it? No, you can't see it through the thing. I'll just hold it. Come on, fan. No, it's cooled down to 41 degrees. Might be a little bit too cool. Let's see if the other one... Those are slightly out. Usually you'd calibrate these according to the data sheet. So you'd have like that third pin, which I cut off, just to put a variable resistor on, so you can calibrate it. But I'm seriously not worried. As long as they turn it on around 40 to 45, that's good enough for me. I mean, if it gets really hot, it's going to turn on either way, regardless of whether it's out by a couple of degrees. So, but if this is in the future and you've got this as a project somehow, you can actually run this just with the one temperature sensor. It'll just detect that the other one's not connected and ignore it. And so it's now down to 40 degrees. Yeah, it may not be enough to turn on. So let's try tip that water out because that's getting too cold now. Alright, that's the last of my hot water. So hopefully that is over 45 degrees. What is it? 42, 44. Yeah, I'll do 40, 44 degrees, 45. Alright, so I want to see it turn on. See the fan? Yep, we can see the fan there. So I want to see it turn on. It should definitely turn on at 45. If it's not, we're going to make some changes. Waiting. Just saw a flash. What's that sensor actually reading? Let's have a look. Oh, there we go. Fan's turned on. Yeah, 3.182 volts is on that sensor that's in there. So that's good. It's 44 degrees and it's turned on. So we should see that turn off now in 30 seconds. Then we will stick this one in, verify that's working. I'm just going to spray this with electrical cleaner after I put each one in water because I'm 99.999% sure that water is not causing the sensors to become damaged, but that's the only thing I can think of that I'm doing that might cause it. So I just dip the top of that sensor in, wait 30 seconds and a fan should turn on. So we're at 43 now, so if this sensor works as well, I'm pretty much ready to install it. Yep, there we go. It's turned on. And I know that these don't turn on at 36 degrees, so cool. Electrical cleaner. So that should turn off in a sec. Alright, what I think I'm going to do now is just leave this powered on. So even though it's not technically measuring anything, the sensors will be driven. So I'm going to go have lunch, do some gardening and stuff. Got tomato plants I need to plant. And we'll be back in about 2 hours and just make sure that everything's still normal. And if it is, we'll be installing it into the UPS. Finally! I'll see you shortly. Alright, we're back 24 hours later, so it's going to give it a couple hours, and I thought, nah, if this thing's going to be permanently installed, I want to make sure it's working at least 24 hours. So I'm not going to stick the thermal probes in water again, because there's no point, but what I'm going to do is measure the output of the sensors, and they should be Yep, that's good. 2.95. It's working. And 2.93. Sweet. So, I reckon our sensors we got from Jaycar were something not right with them. So I might let them know next time I'm there. Just say, hey, I've got these sensors. And, same brand as the other ones. But I noticed the leads were like, they came out differently. Anyway, bit of an expensive exercise. $5.95 for 2 sensors that lasted barely an hour each. That's okay, we've got this working. So now I'm not going to jibber jabber any further. I'm just going to install this into the UPS. I'm going to drill 2 holes in the front of the casing to install these lights. So it's like, you know, temperature, status, whatever. So keep an eye on that. Yeah, then we're just going to glue the temperature sensors to the transformer. I'm also going to install a little heatsink on that. There's a couple of resistors that get quite hot on the board, so I'm going to put like a aluminium bracket on them and then attach the heatsink to that. So that way, not that I don't think they're really getting hot enough to burn out, but that way the cooling, the fan circuit thing I made knows that it's running and something's getting hot. So, you know, that's the point of it, to vent the hot air out. So yeah, all right, then we'll jibber jabber. Let's get to it. Alright, so we're pretty much done now. So as you can see, that mounts externally. I accidentally knocked the glue off the fan earlier, so I just had to glue that back on. So unfortunately I can't reassemble it until that's dried, but I thought I'm actually going to test it in the meantime before I assemble the case. Yeah, so we got 2 thermal probes. So one's on this side, glued and captain taped to this side of the transformer. Reason being, the fan's going to be blowing on this side. You don't want to put the sensor where the fan is, because it's going to obviously cool down this part of the transformer before this part. So yeah, that's the right way to do it. Keep the sensor away from the airflow. The other sensor is attached to this little metal plate there, where there's some resistors under there, which are part of the charging circuit. So that's actually that's not metal against those components. If you saw earlier, I've got a thermal pad, 1mm thermal pad, insulating it between the metal bracket and the components. So yeah, I've just made sure that there's nothing sharp, not that anything's going to vibrate. This was a small concern. There's like a slightly sharp edge on the top, but I noticed when the case is on, it actually pushes that away. But I'll put some tape there cloth tape and captain tape just in case. So yeah, and we've mounted our LEDs in the front. I'll make up a little label for those later. Make sure they're all glued in. Glue takes, it's good to glue this stuff. So, what is it? Loctite extreme glue. I pretty much use it for everything. The only thing that sucks is it takes a while to dry, but it's like almost like a rubbery kind of texture once it's dried, and it's pretty strong. So I like it. So yeah, we've got our controller mounted here. Got some double-sided tape under here, and there's like a little plastic leg clips it on. I don't think I mentioned it earlier. The MOSFET, it doesn't even get hot, but I actually, in this version 2 of the board, I put a heatsink in the board, so that's why it's got a cable tie, and there's actually some thermal paste on there just in case it gets a little bit warm. It's rated at 30 amps, and it's switching like what, 200, 300 milliamps. So she'll be right. And same with the regulator. That's not even getting hot. It gets slightly warm. It only regulates like 23 milliamps, which is like nothing. I've made it so I was going to put it in that plastic box, but I thought I want to get access to the microcontroller should I decide to change the program in the future. Also for safety, I don't think I mentioned earlier, there's a poly fuse there, a 2 amp poly fuse, so if a short circuit occurs anywhere for whatever reason, that poly fuse will trip. Yeah, that's about it really. Now what I'm going to do is power it up and let it run off the battery and try and get it to warm up and make sure that the fans kick in when they get, either the transformer gets warm or the charging circuit. So let's do that, and then once the glue's dried for the fan that I unfortunately knocked off, we can finally put it to work after coming up in 3 months. Alright, decided I'm just going to fire up that mini PC again that I used last time. I don't have a lot of stuff around that's like around the 100 watt mark. I don't know, just plug the stuff into it. So anyway, we'll just plug that in first. Now, the battery. Stick that back here. Hopefully nothing goes bang. I hate this part. Even though I'm pretty sure there's no shorts, there's like, just hate connecting this much bloody current. So, oh, there we go. The thing's powered on. There we go. So the fan's powered. So it basically, I've got like 2 little wires that tee into this. So the fan test ran. Now it's doing the flash codes on the front. Probably can't see that. So it's not actually powered up. It's, so I wouldn't usually touch that. Although it does have paint on it. I don't know. Anyway, let's power on the UPS, and this guy will power on. Yeah. Let's see what happens. Come on. There we go. Let's go have a look. There we go, so it's on battery. It's on do not touch, or you're going to get shot across the room. And the cooler's running. You should see a heartbeat every 30 seconds. Anyway, we'll see the heartbeat. So yeah, she's drawing power. It's not powered on. So, yeah. Alright, so I'm just going to try and find something else I can plug into this, because that is only like 40 watts, as we saw earlier, 2 months ago. Not that long ago, if you're watching this. And try and draw some more power to get some more heat off this thing. hopefully those fans will kick in. I don't doubt that they will. It's just before I like to assemble things, from experience, you like to make sure everything's working every step of the way. Otherwise, you reassemble it, put it up in the cupboard where it's hard to get to, and something doesn't work. So let's find something else to draw some more power off of it. So I've got another computer here. I was actually going to do a video on this. This is my mini Xeon server that I've modified. It's actually meant to be turned off at the moment, so I'm not sure why that's powered up, but yeah, it doesn't actually seem to be any lights on. Oh, that light's on. Alright, so yeah, I'm going to use this as a secondary power draw. Find a cable. Alright, got a cable down here somewhere through earlier. Yeah, there it is. And here we have my daughter's dog, who spends more time with me than with my daughter. And who can blame you, hey? What would you rather do? Listen to Taylor Swift or watch some computer stuff? Woof woof. You good dog. Who's your good puppy? Okay, so I got a little impatient waiting for the other ones to draw enough power, so I've just plugged my work laptop in and done the CPU-Z stress test, just to put a bit more load on it, so we're drawing 52 watts now. And I'm not going to touch it, but I can feel a bit of warmth coming off of it, so it shouldn't be long now until those fans kick in. I'll just note too, there was no audio in that previous recording. If I'm ever dealing with high voltage and I need to get my hands close, I double glove my hands with rubber gloves. Yeah, it's pretty warm now. I'll be surprised that doesn't cut in soon. Just put my finger where the... Wow. It is a lot cooler down this side than it is up the top. That's actually quite warm now. I'd say that's getting close to... I find that I can't hold my finger on something that's 50 degrees. And that's getting pretty close. So I'd say that's getting mid-40s now. But the side of the transformer is definitely not as hot. So I've actually got a meat probe. Let's see what the meat probe says. Usually you're probably saying, why am I using a meat probe? But this is actually pretty accurate thermometer, and it's like fast response. It's basically a thermocouple. I do have a thermocouple for my multimeter, but it's like up there somewhere, whereas, you know, the meat thing is like right here. So we've got 30 degrees. It's not well done until it's 75, if it was a chicken. Come on. 36. Yeah, it's getting warm. 37. I mean, it's not, I wouldn't say this is like... This isn't even the kind of temperature I'd be all that worried about. But any hotter than, you know, 50 degrees, I think it's good practice to keep it cool for longevity, if not anything. Yeah, 40 now. Feels hotter than, yeah, 41. I mean, it's not, the probe's not making the world's best contact either, so definitely the fan should definitely be turning on around about now. Like I said, it's not. I wonder if we could like put the thermal probe down there. See what that shows up as. 41. There we go, 42. These fans should be turning on shortly. 43. Okay. Well, they definitely should be turning on. I'm just going to check the voltages. What's happened there? Oh, my laptop's gone to sleep. Better wake it up. And just as I was about to go turn my laptop back on, the fan's turned on. So there you go, it's working. I did have to give them a kickstart with my finger though. So that's because, remember I've got the two moods, stepped or sine. So it's currently set for sine, so it's going to slowly increase from 40% PWM with increasing fan speed as it gets hotter. So I'm actually going to change it to stepped. And the reason I create those two programs is I know some fans don't mind PWM and some do, some don't. So these fans I don't think are a huge fan of it. So I'm just going to put that jumper on, get to it. Of course there's a wire over it. Hang on. Alright, let's move things around. Yeah, so the fan's just increase in speed because the when the program loops, it checks the jumper each loop. So I mean, you could actually connect a switch to it, but it's kind of like a choose one or the other and then see what works best kind of thing. So just make sure the fans don't stall. Yep. So if I stop the fans with my finger, it starts straight back up. All right, cool. So she is working. Transformer is now getting warm, 53 watts. So the fans, I'm not even going to wait for them to go to the next step because I know they work based on testing with the water. I actually did a lot more testing than what I showed on the camera because if I showed absolutely everything I did, this would be a 6-hour video and not a... Gee, it's coming up to 2 hours. That's pretty bad as it is. So anyway, we're just going to shut it off now and wait for that glue to finish drying and put this together, and we are done. It is then going up into my cupboard and we'll be powering my internet and future network devices. So that's a win. I'm pretty happy. Okay, so I just checked on it, and I was wondering why is the fans running, and then I realised, of course, when the charge circuit is running, it's going to get hot and turn it on. So it's doing exactly as it should because we used a bit of the battery power earlier. So yeah, really happy with the result. The only thing is, I was thinking before, is the load indicator and the battery level is going to be out, and I don't think it's going to calibrate itself, or it would have shown different variable values by now because we've discharged and charged the battery twice, but not a big deal. And in the future I'm actually going to attach a NAS drive here so we can actually hook the UPS up to that and monitor the UPS through the NAS, which will be cool. So yeah, thanks for watching if you've followed this far. And yeah, I'm finally glad this project's over. It's only 3 months in the making. So we can finally move on to other projects. And yeah, that wasn't as bad as the IBM at least. That was what, 3 years, 10 months to complete that project. So all things considered, I'm pretty happy. Glad that it's finally over and working. So thanks a lot guys for watching, and I'll catch you later.